Good morning. Today's session will be about problems based on force between parallel currents. I'll give you the question first. Two long parallel straight wires X and Y separated by a distance of 5 centimeter in air carry currents of 10 amperes and 5 ampere respectively. Currents of 10 amperes and 5 ampere respectively in opposite direction. Calculate the magnitude and direction of the force. Calculate the magnitude and direction of the force calculate the magnitude and direction of the force on a 20 centimeter length of the wire. On a 20 centimeter length of the wire Y. Now let me read it once. Two long parallel straight wires X and Y separated by a distance of 5 centimeter in air carry current of 10 ampere and 5 ampere respectively in opposite direction. Calculate the magnitude and direction of the force on a 20 centimeter length of the wire. Now first we will try to draw this situation. Here given are two wires X and Y. We are given with two wires X and Y. We know the currents through them. Let us mark one current as I1 equal to 10 amps. If I assume I1 is in the upward direction, the currents are opposite, so in the wire Y it will be in the downward direction. Downward direction of current I2 is 5 amps. The distance between the wire is given 5 centimeter. Let us say that is R. Now what is the force? The magnitude and direction of the force on 20 centimeter length of the wire Y is asking. So we'll write here the given quantities clearly. Given current I1 equal to 10 amperes. Current I2 is equal to 5 amperes. 5 amperes. Also given distance between the wires, or the gap distance between the wires, is R equal to 5 centimeter. Now the force magnitude, we know the formula. It is mu naught by 4 pi into 2 I1 I2 by R. Now let us substitute the formula and try to find out the force. Next I will write force per unit length is given by force per unit length between two parallel current carrying wires as F by L is equal to mu naught by 4 pi mu naught by 4 pi into 2 I1 I2 by R. Now here therefore the force on 20 centimeter length of 20 centimeter length of wire Y is F is equal to mu naught divided by 4 pi into 2 I1 I2 divided by R multiplied by L. This is the equation of force. Now let us substitute the quantities one by one. We know mu naught is 4 pi into 10 to the power minus 7 divided by 4 pi into 2 I1 is 10. If you can recall, I1 is 10 and I2 is 5 and R is 5 centimeter. Divided by R is 5 centimeter. Convert that into meter. 5 into 10 to the power minus 2 multiplied by 10 is L is 20 centimeter of the wire. 20 into 10 to the power minus 2. Now simplify this equation. Four pi will cancel. 10 to the power minus 2 10 to the power minus 2 will cancel. Now do the remaining calculation. And here also 5 and 5 will get cancelled. So 2 into 20 into 20, that is 400. 400 multiplied by 10 to the power minus 7. Multiplied by 10 to the power minus 7 Newton. Force unit is Newton, or it can be written as 10 to the power 2 10 to the power minus 7, that will come to 10 to the power minus 5. 4 into 10 to the power minus 5 Newton. So finally you can write force on, so here the magnitude of force on a 20 centimeter length of wire Y is on 20 centimeter length of wire Y is 4 into 10 to the power minus 5 Newton. Now what is the direction? Now because the currents are acting in the opposite direction, the force will be of repulsive in nature. The two currents are acting in the opposite direction. The two parallel currents, two parallel currents are in opposite direction. Therefore, force is repulsive in nature. So, therefore, F is acting away from wire wire X. Now the force F will act away from X. So this will be the force F. Repulsive in nature, therefore force on Y will be acting away from X. Because we have seen that if two currents are in opposite direction, the force is repulsive in nature. Similarly, if two currents are flowing in the same direction, then the force is of attractive type. So remember, if two currents are flowing in the same direction, the force is attractive type, and if two currents are flowing in the opposite direction, then the force is of repulsive type. Hope you understood this problem.